Hello, I'm Sonic. We will learn about differentiation only. Now we go ahead in full detail. Differential calculus is a subfield of calculus concerned with the study of the rates at which quantities change, also called derivative function. We will discuss one by one. Differentiation with variables. Differentiation with operators. Differentiation with trigonometric functions. And differentiation with inverse trigonometric functions. First, let's start with variables. As you wish, you can have a variable x by applying a derivative function. I'd like you to show this limit function. We have limit of h tends to 0, f of x plus h, minus f of x, divided by h. For example, if we take f of x as a square function, equal to x squared, and is differentiable at x equals 2. You may like to mean derivative f of x is called d over dx. Its derivative is 2x. And if x equals 2, we get the derivative value 4. When you solve the limit at x equals 2, we get 4 plus h. But h tends to 0 to get 4. In a shortcut way, generally calling x to the nth exponent. Differentiating with respect to x, we now get n times x to the exponent of n minus 1. That's one-time differentiation. Again, if you want to differentiate it, we now write d2 over dx squared, equal to n times n minus 1 times x to the exponent n minus 2. So far, when you keep solving them for higher order derivatives, we write dn over dx to the exponent n is equal to n factorial. Well, hey, that's a nice idea. It's like a factorial pattern, by the way, just like in permutations and combinations, where Officer Knights had taught you. In case, what happens if you do not use variables? We get the value 0, as you differentiate it. This part is just only called the differentiation of variables. In the next part, we'll tell you about the differentiation with operators. Like, comment, and subscribe now.